Hi, in the last video, we have seen the concept of voltage and frequency. Now, in this video, we'll try to see another important concept with respect to AC, that is current. Now, you may have a question that we already call it AC, that is alternating current. Then what is the why we use another current concept? Now, I can't help it. So, just the continuously changing supply is called as AC and the constant supply is called as DC or direct current. So, these are the terminologies, and the electric current that we are going to discuss now is the actual flow of that energy. Again, I will not go too much technically, I will try to understand it conceptually. As I told you that there are 2 points in AC voltage, one is called as phase, another one is called as neutral. Now what is happening here? I told you that there is AC supply which is moving like this. Now it's okay, it is moving like this, and one point is at a higher potential than the another point. You have to consider this, and it is always best understood with the terminology of water. So there is an overhead tank and there is a tank on the ground. The overhead tank usually is at a higher potential, and just a moment, I'm taking highlighter instead of an eraser, and let's continue. So the overhead tank is, let's say, filled with some water, and we are going to connect that with the tank which is present on the ground. Now what will happen? Naturally, because this is at a higher potential or higher height from the gravity point of view than the lower one, what will happen? The water will flow from this tank towards this tank. First concept. So this first concept is important to understand, that when there is a phase which is having a higher potential than a neutral, then whenever you give some path to it, or whenever you give some electric path through it, then what will happen? The energy is supposed to flow through this path. Now the next question is, if I have to move the water, what I have to use? I have to use something shallow. Okay, it means there has to be some kind of shallow pipe which will take this water from the upper tank or tank A towards tank B, correct? If the pipe is not shallow, let's say if I connect this with an iron rod, what will happen? Nothing. There might be some leakage, but no such water flow. So what is this? This is your conductor. Who is conducting your water? A shallow pipe. It may be made up of plastic, it may be made up of metal, it doesn't care. But it should not have any holes in between. So it will properly let the water flow through it. In the similar way, we also need a conductor for this energy to flow. And regardless of whether you have AC or DC, the conductors of electricity are metals. All metals are good conductors of electricity, but those which are very good at conducting the electricity and are relatively cheaper or can be used or most popularly used are copper and aluminium. Gold and silver are also very good conductor of electricity, and they are used at some places. You might see the microprocessor pins sometimes are made up of gold, or either they are gold plated because they are highly conductive. So all metals for now considered are conductors of this electricity. Now let's come to the A and B water tank scenario. So this is your conductor. Now how much electricity is going to flow through it? It will depend upon the size of this conductor. How it relates to electricity, we'll see that in short. So this is at a higher potential. First of all, so what is needed? You need a higher potential and you need a lower potential, and you need some conducting path. Then there will be a flow of water. In the same way, you need a higher potential like phase, you need a lower potential like neutral, and then there has to be some conducting path for the electricity to flow through it. Now usually what happens is, whenever if you try it, and if you don't, I warn you, don't try it at all. We never connect a single wire between phase and neutral, because what happens is, the wire or any kind of metal is a very good conductor. And if you just apply a wire between phase and neutral, it will try to gain a very high amount of current and thereby cause a short circuit, and it will damage something. Now then, what exactly, how do we avoid short circuit, or what should be the thing coming in the picture in order to understand the current very well? So to understand the current very well, what we need to do is, we need to introduce a concept called as resistance. This is also called as resistance, or in a very simple language, I'll call it as load. Now what is resistance and what is load? I'll give you with a very simple example. Let's say you are playing football, okay? If I'm playing football, for example, then I kick the ball with a hard force, okay? First example is with football. I kick a ball with a very hard force. Let's say otherwise, if you are playing baseball or if you are playing a cricket, what you do is, you have a bat in your hand and you hit the ball with a steady hard force. Now while kicking the football, the ball is my load, or while hitting the ball, while hitting with a bat, the ball itself is a load. Now let's assume there is no ball present and you are trying to kick something. What will happen? With that much force, when you put your leg forward, you may fall behind or something like that. So there has to be an application. Why are you kicking? Why are you kicking your leg? Because you want to move that ball to some place. In the similar way, there is always an application of electricity. Why do you want it to flow through something? Maybe you want to generate light. Let's go to the basic necessities of humankind. We used electricity, we invented electricity to either generate light, or we wanted to generate heat. There has to be some purpose, right? And whenever you want to do something, and for that cause when you use electricity, then this is your load. You have to give some kind of load between your wires or between your conductor for the energy to flow. Let's come it again. This is, I'll just use it as a symbol of AC supply. Let's consider phase and neutral. These are wires. There is a load, and then you connect it to neutral. So whenever you create a circuit like that, your load will turn on. If it is a bulb, then the bulb will glow, something like that. Here the voltage is denoted by V, and the current flowing, I should not give direction because it is AC, the current is denoted by I. And this load is offering some form of resistance to the energy, which is denoted by R. This R is usually V upon I, or you can also say the current I is equal to voltage upon resistance. I promised you I will not go much into technical stuff, but this is the least important, or this is the least I will do, but this is most important, I would say, not least, most important. Let's say I have a very good conductor. Let's say I am using a copper wire and I simply short the AC supply. What will happen in that case? See, your current is voltage, let's say it is 230 volt. A common wire offers almost zero resistance. So let's say the resistance is 0. It's a good conductor. There is no resistance to the energy. So what will happen? It will try to gain infinite amount of current. Now in practice, a wire will never have 0 as its resistance. It will offer some resistance, but even in that case, it will try to have very high current, and the entire circuit comes into something called as short circuit condition, and it will blow up, it will break up. Now this resistance is important. Every kind of load will offer some resistance. It is dissipating some energy. Let's say there is a lamp, or let's say there is a filament lamp. So what is happening? It is generating some heat. While generating the heat, it is dissipating some of the energy and thereby resisting some of the energy and generating light out of it. In a simple term, this R or resistance is V upon I, and it is measured in ohms. The symbol is omega. So the resistance is measured in ohms. This is the concept of resistance, voltage and current, and this relation R is equal to V upon I. Why it is called ohm? Because it was invented by a scientist called Ohm, and this is also called as Ohm's law. The Ohm's law is V upon I is equal to R. That much mathematics, I would say, will help us a lot in doing all the different electronic experiments. Things may still not be very clear to you, and it's completely okay. Just try to understand the concepts. We are here trying to understand everything with the perspective of AC. The entire concept of voltage, current, resistance remains the same in terms of DC, only the nature of the source or the supply changes. So, to summarize, there will be a current flow whenever there is a path. There will be current flow when there is path between electric points. This current is denoted in amperes. I told you unit of voltage. So the current is measured in amperes, voltage is measured in volts, the frequency is measured in hertz, and the resistance is measured in ohms. These are the concepts we discussed so far. Current, voltage, frequency and resistance. We'll explore all these concepts in a bit more detail when we start with the DC voltages, and we'll try to understand all these things one more with the DC voltage. I hope it's somewhat clear to you. Completely fine. If there are still many doubts, they will be cleared as we go through the course. Thank you for watching this video. In the next video, we'll try to understand about the DC voltage.